Okay, so in VBA, an array is an ordered series of, any guesses? Okay, we're now beyond the point where you think you know, and just take a guess. Of what? Of cells. No, it's not cells. Well, elements is kind of a safe word because, yeah, but I mean, that's just like, what makes up the array. But what are they? It's actually something that exists separately from the array. Yeah. Objects. A really good guess. Not right. So here's what it is. In VBA, an array is an array of variables. So when I create a variable, dim x as integer, I am allocating 2 bytes of RAM to be able to hold that information. And that is one variable. But I can create an array of hundreds or thousands or tens of thousands of variables all at once. Do you remember what a variable is? A variable is, and kind of go back to the slide that we had like on the second day of class, it's a location in memory that has a name. And so we say we got some location in memory, we give it a name, and we can put information into that. We can read information back out of that. And when I create an array, I am making an array of variables. So an array is always an array of variables of the same type. So we don't get to, in fact, the computer science definition came up. Read that one again. You still have it up? Same data type. That's what I was after. It's the same data type, and that's right. So when we have an array, I'm going to have, I might make an array of 100 variables. They are all going to be the same data type. That's kind of characteristic of what an array of variables is. I don't get to say, oh yeah, it's a what's the definition again? An ordered series. It's an ordered series of variables, and this one's a string, and that one's an integer, and this one's a long, and that one's a byte. No. They're all going to be the same type. So the thing to realize here is that I use an array when I'm saying I've got a whole bunch of variables I want to declare. Now, because I declared all those variables as an array, it gives me some extra flexibility than just having declared 100 different variables independently. And we're going to see what that is here just in the examples that we work on today. All right, so let's just start off by seeing how do we declare an array. Oh, I've got our locals window open. I'm going to close that. All right, so here I am in module 1 sub. I'm just going to call this initialize. I-N-I-T-A-L-I-Z-E. Initialize array. Now, yes, go ahead.
For VBA, you say an array
Oh, so okay, so you're thinking about Python. In Python, we have a structure called a list. And a list and an array are very similar to each other. They're, I'm trying to think about my experience with lists in Python. I'm trying to remember if lists in Python have methods. Like I know in JavaScript, arrays have methods. And that's not the case in VBA. I'm not sure if they do in Python, do they? Yeah. Okay. So yeah, so in Python, you have an array that you make a list, and then you can call methods on that because it's really an object. And there are no methods for arrays in VBA. It really is just an ordered series of variables. And there are things that we can do to arrays, but arrays don't know how to do anything by themselves. Objects, when you have calling a method of an object, that object knows how to do something. It knows how to do something. Arrays don't know how to do anything. They are just an ordered series of variables. And here's how we do it. Now, let's just say I was going to declare something to hold the name of a hotel. Dim hotel as string. That would declare one variable of type string, right? And when this line gets processed, it's the VBA interpreter says, "Hey, operating system, I need some memory to keep track of a string." And it goes, "Great, here's some memory, here's an address, and it's all yours." And then the VBA interpreter keeps track of the memory address that is, and the fact that I want to call it hotel. So I don't ever, as a programmer, have to worry about what the address is or anything. I'm just going to use that name, and my interpreter is going to keep track of where that is in memory and allow me to put things in, pull things out of it. To declare an array of variables, I want to declare more than one. All I do is right after the name, in parentheses, I put in a number. 99. And so now this statement does not create one variable. It now creates how many? That's a trick. It creates 100. And the reason is because arrays start counting at 0. And what you're putting here is not how many you want, but what you're putting here is the upper boundary of the array of variables that you're creating. Now, as it turns out, in the early days of BASIC, long before we had Visual Basic or Visual Basic for applications, there was no statement to actually declare a variable. So you want to declare a variable, you would just use it. It was one of the kind of the novel things about BASIC. You would just use that variable, and it would the interpreter would then allocate the memory for it. Go, oh wow, you've never used this before. I'll go allocate the memory for it. It's really kind of slick. And you would actually put data types on it. It was interesting because if you're going to just use a variable, and I think you can still do it now. I could say name equals Fred. Debug.print name. Now, because I have option explicit turned on, I can't just use this name before I declare it. So I'm going to comment that out for a moment, and we'll see that should work. Run that with F5. I think I'll run that. Yeah, so it prints out Fred, and so it kind of still works this way that we could say just use the variable, but you could even give it a type as well by putting a different symbol on the end. So if I said name $, that would declare that as a string variable. I'm not sure if it still does that. That's a good question. I'm going to find out. I haven't asked this question for like 20 years. I don't know. Debug.print the type name of name $. Yeah, it actually knows that's a string. And I wonder if it'd be a variant if I did it without it. Might know it's a string anyway. Name $. Anyway, that's not that the fact that that's how we used to declare variables isn't important. But the point, what I'm trying to bring up here is that we used to not have a way to declare variables at all. We could always declare arrays. And this is how you declared an array in BASIC, from the very early days of BASIC. And so because what an array is, it is declaring a bunch of variables at the same time, an ordered series of variables at the same time. When they wanted to come up with a statement to declare a variable, what did they do? They took the statement for declaring an array and they said, oh, let's just take off the parentheses, and now you've got declaring a single variable. That's where the term dim comes from. You're setting the dimensions of the array. That makes sense to talk about the dimensions of the array, and yet they use the same statement to declare individual variables later on. Okay, now here I have declared 100 variables. They're in an array called hotel. And I am going to now see how I refer to them. If I want to put one of these in, I'm going to say hotel. And it doesn't make any sense for me to say hotel, and give it some name. This is the Hotel California. This doesn't make sense because now it's like saying, listen, you got 100 of these. How many, which one are you talking about? And so to refer to an individual element in the array, I am going to put an index. And because arrays begin starting at 0, counting at 0, that would be my first one. And so now I can think of the variable name and treat this just like any other variable, like that's the name of the variable. And I could use this just the same way I'd use any other variable. So I could print out the name of that hotel, debug.print hotel 0, and that's going to print California. But the part that then is really powerful here is that I can use a different expression to be able to put this number in, because that is a number. So I can use any expression there that evaluates to a number. What this will let me do is it will let me plug in, just do this. Let's declare dim x as an integer for x equals 1 equals 0 to 99. Next, hotel sub x Now remember, the first time through this loop, X is going to be 0. So that would be exactly the same thing as hotel sub 0. Next time through, it'll be hotel sub 1, sub 2, sub 3. And I can set that equal to something. I'm just going to read the time off the system clock. And then I'll print out hotel sub X. I'm not sure that that will happen, over, something that breaks for a second. It might print out exactly the same thing. Let me go ahead and print out. You go ahead and print out X as well here. Yeah, it happens so fast that we don't even get 2 different seconds in there. It's all happening on the same second. But what's powerful then here about the array is the fact that I can now use a different expression to identify which of the variables I'm talking about. So I can now kind of process like a whole bunch of variables in a similar and automated way. With a variable name, if I want to talk about a different variable, I've got to type the different variable name. But now with an array of variables, I can use an index number that can be any expression like a variable here, just like, as we've done here, and refer to multiple of those at the same time. Questions? Okay, maybe I would actually put in here something like x times 3 as the value that I'm putting in. X times 3. And that would see that we've got both now X printing out as well as whatever that number times 3 is. I guess that's 99 times 3, 297. Okay, show me how comfortable you are with what we've covered so far about arrays on a scale of 0 to 5. It looks like you're feeling pretty good about it. It does get a little more difficult, and let's look at how it could get more difficult. The first thing is that we have this option explicit, and these options that we put at the top of a module, those are what are referred to as compiler directives. Now, there's not really a compiler in VBA. It's an interpreter, so I guess we'd call it an interpreter directive, but we don't often, it's like a term I'm not really familiar with. What this says is, this is not a statement that executes, this is a statement that tells the interpreter how to understand the rest of the code. And so it's saying, while it's going through and trying to figure out the rest of this code, these directives at the beginning that start with option tell it, this is how you should process that. In other words, if I forget to declare a variable, tell me. That's what this says. It's telling it how to process the code. And there's another one that I'm going to expose to you right here called option base 1. What option base 1 does is it says, I want my arrays to start counting at 1 instead of start counting at 0. And that's a really tempting thing, because normally, where do you start counting in life? You start counting at 1. And so if I could get my arrays to start counting at 1, my life would be moderately easier at this point. I want to kind of expose you, let you know that's possible, but we are not going to use that here. The reason is that if you have learned how to manipulate arrays using a 1-based array, and you think, this is great, this is how you use arrays, and you come across someone else's code that is a 0-based array, it is a major shift for you to be able to change your understanding from 1-based to 0-based. It's easier to get going, but almost everyone declares their arrays as 0-based arrays because that's the default. If you've taken a little more effort to get comfortable working with 0-based arrays and you need to adjust to a 1-based array, it's really easy. And so we're going to stick with 0-based arrays because it's the right way to learn to work with arrays. Arrays are 0-based in almost every language. And so we're going to go with that one. Yeah. So the question is, what's the advantages or disadvantages of a 1-based array versus a 0-based array? The advantage of a 1-based array is that when you declare 99, when you dim it at 99, it makes 99. And so you don't have to look at that and remember, oh yeah, that's not the number, it's the upper index. It's a little more natural to think I'm going to start counting at 1. It's not huge values. It's not like a huge benefit to declare it at 1. The reason that arrays count at 0 is because what's really happening in memory is that you remember that a variable, is a named location in memory. And what happens with an array is that we get a name, hotel is the name for one location in memory. It's the starting point. And what the number that I put in here, it's an offset from that starting point to know where I'm going to actually read that memory. And so because it's like how many variables I'm moving away from where it starts, that's why it starts with 0, because it's an offset from the start. And so the very first variable in the array is at the location it's at that location that has the name of the array. And so that's the reason kind of historically in computer science why arrays are 0-based, is because it's a certain number of bytes offset from that location. So yeah, there's really not much of a benefit one way or the other. It just makes your code a little bit more readable. There's actually something else that we can do here, is that I could declare this. I could actually do it without the option base. I can declare hotel, dim hotel, like this, 1, 2, 99. And that would create, I can actually tell it, what's the range I want. This can be really handy if it happens that your arrays are dealing with like years, because you might say, listen, I've got the range of years from 1980 to 2050. I can declare an array from 1980 to 2050. And then I can actually use the year to refer to the offset in the array that I want. So this is it's possible to do this. We're not going to do this either. We're going to stick just kind of with the default way that it happens as we're kind of learning this stuff. Other questions? Okay. So as it turns out, this is what we refer to as a one-dimension array. And I'm going to change this. Instead of 99, I'm going to put it to the number of hotels we actually have. So let's go ahead and talk about the problem that we're going to solve. And then we'll look a little more at arrays. So just suppose that you've taken your first job, and you've taken a job working for the Western Division, for the Western Region office of the Starwood Corporation. The Starwood Corporation owns several hotel brands with which you are familiar. So you've heard of the Westin, you've heard of the Sheraton, you've heard of the Four Points. These are all properties of the Starwood Corporation. So you've taken a job, right after you graduate, you're going to go to work for the Western Region office. And the person who hired you is like, look, no one knows you work for us yet. And so I'm going to give you a list of some hotels that I want you to go and really kind of find out how things are going at these hotels. So before you show up for your first day of work, you got I don't know how much you're gonna get. You're gonna get like a month, 2 months. Well, let's see, how many of them are there? We're going from 2 to 37. So there are 36 properties. You've got 2 months to go to these 36 properties. We're gonna rent for you a van. You're going to take the family and you're just going to go from property to property. And what are you going to do? We're going to give you a credit card and you're just going to spend. You'll check in with the credit card. You're going to eat at the restaurants. You're going to go to the masseuse. You're going to do everything there. And you're going to make a report about how you think each of these properties are doing. Some of these properties that you're going to visit are really doing well, we think. And some of them are really struggling. And we want you to kind of identify, what you think is going well at these, what you think is going badly at these. Okay. So you say, well, great. Well, what order do you want me to go to these in? And your new boss says, I don't care what order you go. Go, whichever order you want. So describe to me the order that you want to go to those 36 properties in. Or describe to me a characteristic of the path that you're going to take to go to all 36 of these properties. You want the way you go to be say it louder, the shortest possible. I want to take the shortest route to go to all of these. Why? Because every minute in the van with the kids is one less minute with the masseuse, right? For sure. And so, yeah, you'd like it to be less. Okay, so, and here's what we have. If we look at this chart here, we then have these 36 properties, and then we have the road distances between every pair of properties. So here, there's, on the diagonal, that's the distance between this property and itself. But on this row, then we see the distance between this Sheraton in Los Angeles and the Sheraton in Salt Lake City, the Sheraton in Phoenix, the W in Scottsdale, the Phoenician, the Westin in wherever that is. And so you've got the road distances between every property. So that's what you've got to work with. And your job now, and what we're going to do is we're going to calculate, we're going to have VBA calculate a route for us to go. So let's talk about how we might go about, what's the algorithm that we're going to choose to be able to figure out how to go. Any thoughts? How might we do this in a set of steps that we could tell VBA to do to calculate the route for us? Go ahead. Okay. So we're going to start in Salt Lake because that's the closest one to us right now. And what you're describing is you're saying, if we were to name that algorithm, you'd say it's like the next nearest hotel algorithm. So we'll start here, and then we're going to say, all right, we've now been to this one, and we'll say, what's the closest one to where we are that we haven't been to yet? Go there next. And then from there, that'll be in Las Vegas, by the way. So we'll go to Las Vegas, and then we'll say, all right, what's the next closest one? By the way, who's the closest one to Las Vegas? Happens to be Salt Lake. You come right back there, but you have the extra constraint that says has to be ones that we haven't gone to. How many of you are familiar with this problem? It's kind of a famous problem. Yeah, what's it called? What's this problem? There's a name for this problem. Do you know what it is? It's called the traveling salesman problem. So, I mean, it happens that we're not a salesman or person, but I mean, we're just going to these all hotels. But this idea that you've got a route, you've got to go to all these places, and you want to go in the shortest route. It is a problem that literally we have mathematicians have been working on this since the 1700s. It's like an old problem. We're trying to figure out, what's the best route. This route that we get is called the next nearest city route, and it is virtually guaranteed not to give us the shortest route. It's pretty easy to calculate, and that's actually it's the algorithm that we're going to do here in class because it will give us a route, and it'll be a pretty reasonable route. Chances of it being the shortest route is really, really small. So other ideas, it is possible to calculate, to figure out what the shortest route is, but there is only one known solution to this problem. There's only one algorithm that's guaranteed to give you the shortest route to this problem. Do you know what it is? Yeah. Calculate all possible routes and then just find out the length of every single route and then just see which one's the least. We've been working on this for like 250 years. And that is still the only algorithm guaranteed to give us the shortest route. Now, what are we doing? We're saying, well, listen, what if we could be 95% sure that we found the shortest route? Are there some shortcuts we can take? Yeah, there's lots of shortcuts, and really brilliant people have come up with ways to say, yeah, we can kind of shortcut this, but that's the only known solution. Well, when I first did this example, I thought, hey, I'm going to figure out what the shortest route is. And I thought it's going to take a while to do all that calculation in 36 cities. But I got a computer and I could just let it run. It'll take a while. We'll let it run. By the way, with 36 cities, how many possible routes are there? I'm always amazed that someone will know the answer to this right on the top of their head. How many possible routes are there between the 36 cities? It's not 2 to the 36th. 36 factorial is what it is. Fortunately, we have a function in VBA or in Excel for doing that. It's called fact. So I say factorial 36. And that is, I never was very good with scientific notation. Let me make this into regular old numbers. I don't need the decimal points. Oops. Okay, that's how many possible routes there are. And when I first did that calculation, I thought, my computer's pretty fast. It could probably do it. And so, like, I set it to run, went home, came back the next day, it hadn't finished. And so I stopped it and I said, I wonder how fast I can, how long does it take me to calculate a route? And I found out, this was a number of years ago, I found out, my computer was pretty impressed. It can calculate 5,000 routes in a second. So how many seconds is this going to take? That divided by 5,000. That's a lot of seconds. How many minutes is that? That divided by 60. How many hours is that? That divided by 60. At this point, I went, oh, I don't think I'm solving this problem computationally. One computer is not going to be enough. I'm going to have to get more computers involved. Actually, that's what are we at? Is that hours? Let's go ahead and get to let's get to days at least. This equals this divided by 24. Did I do that right? Yeah, this equals this divided by 365.25. That's how many years it would take to calculate to find the correct answer here. I got to have more computers involved. I read not long ago that the 1 billionth PC had been produced. So let's use that as kind of a surrogate for the processing power of humanity. Take that and divide it by 1 billion. It's still that many years to figure out what's the best scientific estimate for how old the universe is. Anyone know? It's like 13 billion years. That's really good. I don't know why you knew that. That's pretty good. This equals this divided by 13 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's finally a number I can say. 0.63, by the way. That is hundreds, thousands, millions, billions. If I was to dedicate the entire processing capacity of humanity to solve this problem, it would take 181 billion times as long as the universe has been in existence to come up with the correct answer. The truth is, you can drive the worst route dramatically faster than you can calculate what the best route is. That's amazing to think. Is this a problem that has like real implications in business today? Yeah. I mean, you think about like Amazon has to go deliver stuff, UPS, Federal Express, they all have to plan out routes. And they would really like to be able to make those the most efficient possible. Now, these are even more complex because a left turn is more expensive than a right turn is. And so, I mean, the problem ends up being pretty complex. You see why mathematicians have dedicated their careers to trying to shortcut this problem and come up with the answer. Yes, go ahead.
It takes that long to find the right answer.
Yeah.
How did they initially find out that the answer they found wasn't the shortest answer?
So how do they know?
Yeah.
Well, that's the point. Yeah. Is it possible that the next nearest city algorithm could give you the shortest route? Yeah, it is, but you can't be sure that it's the shortest route. You want to say, give me an algorithm that will give me the shortest route. Next nearest city won't do it. It might, coincidentally. A random draw might give you the shortest route. But you want to be sure that you've got the shortest route. There's the only one algorithm that will do that. You can do this, by the way, computationally, you can do this up to about 25 cities. After 25 cities, it just explodes. It's too big to be able to solve by brute force. So, and we're going to use arrays to help us come up with the route. So we're going to calculate the next nearest hotel algorithm to do that, and we're going to do it with VBA. Should we get started? Let's go ahead and get started. All right. So I've already got started here with the array. And so I'm going to get rid of this. I'll leave that loop in place for now. So I've declared hotel here. And let's do this. I'm going to kind of introduce a couple of different ideas. The first idea I'm going to show does not have to do specifically with arrays of variables. This has to do with all variables, and it's referred to as the scope of the variable. So far, the only place we've declared a variable has been inside of a subprocedure. When I declare a variable inside of a subprocedure, when that subprocedure gets loaded into memory to be executed, that's when all the variables that are declared inside that subprocedure get allocated. So we say, hey, we're going to call this, and the VBA interpreter says, great, let's go get all the variable, all the memory we need for these variables. And when we're finished with the end sub, it gives the data back. It gives that memory back to the operating system. Well, what I'd like to be able to do is have these arrays sit around so I can have different sub-procedures running, kind of starting and stopping and running, and be able to access the same memory. I want the array or these variables to be accessed from multiple sub-procedures. To do that, I need to declare these variables somewhere else. And that is, instead of declaring it inside of the array, I'm going to declare it up here at the top of my module. After my directives, I'll just put the declaration up there. It's like the only other thing besides a directive that you can put outside of a subprocedure is declaration of a variable. In this case, we're declaring a bunch of variables together. Like we might come here and say, I probably better actually put the number back in there. So I want to have 36 hotels. So what number do I put here? 35. So now I'm allocating 36 slots in memory. And it's going to start with this at this name hotel, and I'll use that number to indicate how many I'm offsetting to get to the one I'm after. Now, what's nice about this is that when my code starts running, it's going to allocate that memory, and it's not until all of my procedures are done running that it's going to go, now we're done with that memory. So as long as I've got procedures running, they can call each other, and all these procedures now that I have here will be able to access this variable. So this is now a module level variable. The scope of the variable is the module. Down here inside a subprocedure, this X here declared inside the subprocedure, the scope of this X is just to this subprocedure. If some other subprocedure wants to refer to X, it won't even have any idea what it is because it's not in scope. But any of my subprocedures in this module can refer to this variable because it's declared up here. If I want a variable to be available across different modules, then instead of using the keyword dim, I use the keyword public. And that would make this into a global variable, or this array of variables would be global. So now even subprocedures that are in different modules can access it. I'm going to go back to, we only have only one module here. So I'm going to go back to dim, but you have those three levels of scope. You have module level, which is the one in the middle. You have global, which is kind of for your whole application. And then you have local or procedure level scope, which is only available inside the subprocedure. And the general rule is you want to declare the variable at the lowest scope to accomplish the need that you have. And the reason is that if you have 3 or 4 different modules out here and you've declared these things globally, it's not always clear to you where that variable was declared, and you might accidentally redeclare it. And just having variables with the same name declared at different scope can be really confusing. And so you want to declare it at the lowest level possible. Okay, so now let's do this. Instead of hotel 0 equals California, I just want to read the names of the hotels off the worksheet. So I'm going to dim, instead of dimming X, why don't I do this? I'm going to dim row as an integer. And we're going to start row off at 2. Row equals 2. And then we're just going to iterate across these rows as long as we have data. We're going to read the hotels right here off of our distance sheet. Now that distance sheet may be named. Yeah, it's called distance. It's both of its names. Its code name and the worksheet name are both distance. So what I'm going to do is make this, instead of a for loop, I'm going to make it a do loop. Do until distance dot cells, row number row, column number 1, till that value is equal to a 0 length string. I'll change my next into a loop. I'm going to have to now increment row myself. The for loop automatically increments my variable. The do loop doesn't. And so I'm going to come in here and say row equals row plus 1. Anytime I have a do loop, it's always a good habit to put in do events. Just in case I put myself into an endless loop, I'll be able to break into it. And now I want to read off the worksheet and put the values into my array. Let me start off just by printing the values so I can see that I'm getting there. So debug dot print. My worksheet is called distance cells. Oh, I already got it right here. So I'm going to print off row and whatever is in the first column of the current row for that. And then what I'm expecting that to do is just print off the names of all of the hotels. And that's great. On row 2, we've got that hotel name, and that's the first one. And it goes all the way down to the Sheraton Santas. That should be at the North Pole. Oh, never mind. It's not Santa. The last one here. Okay, so that looks like good. So I've got those. Now what I want to do, instead of just printing them, I want to put them into the array. So the first time, and I'm gonna kind of write this out just so I can see it. The very first time, and then we'll simplify it. I want to say that hotel sub 0 equals in fact, let's go ahead and I'm going to write it like even without the variable. The very first time I execute this, and what we're doing here is kind of a little instructive so we can kind of see what we're after, and then we'll generalize it. So when I'm looking at row number 2, I want to write into the 0 spot in my array. I want to write into the 1 spot of my array with what's at number 3. I want to write in the 2 spot of my array for what's in row number 4. Okay, so this is what I actually want to execute. And so I've already got row set up to start counting at 2 and move up. So I can make a general version of this statement by saying, like, I can produce that vector here, 2, 3, 4, etc., just with the variable row. But how do I produce this vector of numbers, 0, 1, 2? What can I put here then that will be general? Yeah, just row minus 2. Excellent. And so now when I'm looking at row number 2, this expression will give me the 0th element of the array. When I'm looking at row number 3, it'll give me the number 1 element of the array, and so forth. And so that should load that array up. I'm going to go ahead and put a breakpoint here, just write stop as a breakpoint in my code. So I can run to that point, and then I'm going to kind of poke around at the array and see what I have in there. Okay, so because I have this breakpoint here, this sub-procedure is still loaded in memory. I can still refer to that array and take a look at it. I'm going to come to my immediate window and just see. I would expect my very last element of the array to be the Sheraton Santa's Hotel. So my array is called hotel, and I'm looking at the number 36. The number 35 element, the last element. There's 0 through 35. It's 36 properties, and there it is. That looks great. The first one, that Los Angeles one, should be in the number 0 spot. The one in Salt Lake City should be the number 1 spot. And so, yeah, it looks like we've got at this point, so we've loaded up that array. So that array of variables now is holding the names of my hotel. Question over here.
In other languages, you can print the entire array.
Ah, yeah, you can just say, hey, just print the array, and it will kind of put the whole thing out. That was a really great innovation, like way after 1995. And so if you're going to print something, it's got to be a primitive. Yeah, unfortunately, you can't just say print that whole array. But what you can do is I could open up my locals window. So view locals window, and that's a module level variable. So I'll open up module 1, there's hotel, and I can see all the values here. So that's like the idea behind the locals window, so you can just kind of see everything at the same time. I had like programmed in VBA for 15 years before I even knew there was a locals window. So it doesn't like occur to me to use that very often. Okay, so far so good. How are we feeling on what we've done so far? 0 to 5. 5, 5, 5, 5, 5, 4.5. Okay, we're about to make it harder. First thing we're gonna do to make it harder is we're gonna say, sometimes we don't know how many variables we want at the beginning. Like, is there going to be 36 hotels or 37? I'd like my code to work. If I update this table and add 4 or 5 more hotels, I'd like it still to work without having to go in and change how many I'm declaring. So that's what we refer to as a dynamic array. So right now, what we have is a static array. Static array is I tell it how big it's going to be, and that is it. That's how many variables are going to be declared. A dynamic array, I can figure out how big I want to make it after the code starts running and then make it that size. And I can change it to a different size while it's running. To do that, to make a dynamic array, in fact, let me just go ahead and leave this as a comment. This is a static array. To make a dynamic array, I am just going to take out the number from inside the parentheses. Dynamic array. The important part to realize here is that variables get allocated at the moment that I load the procedure into memory. So before any other code runs, I've allocated the memory. So what I can't do is this. Let me dim hotel count as an integer. I think I'm trying to convince myself to use snake case instead of camel case more often, as integer. How could I read off the worksheet what the hotel count is? Hotel count equals distance which row do I want to look at? I want to look at the very last row. So I'll say distance dot rows dot count. So how many COUNT? How many rows are there on my distance worksheet? 1.02 million. And so this expression will be 1.02 million. This will be the very last cell in that first column. From there, I want to say end XL up, and that will come up until it bumps into data. So that will be referring to this cell 37. And I want to ask the row of that, and I want to minus 1 because my hotel count is how many hotels I have. This starts counting on row 2, so I'm going to subtract 1 off of it so I can calculate how many hotels I have by reading that off the worksheet. Excellent. What I can't do is this, dim hotel at hotel count minus 1, because I want that to be 35, so I get the 36 values. This won't work. The reason this won't work is because even though the dim statement comes after I've calculated the value for hotel count, I mean, it's okay to put it here in the code, but every dim statement gets processed before the rest of the code runs. Like when that procedure loads in memory, step 1, allocate all the memory we need. And so this line actually gets handled before this one does. And so it won't know the value of hotel count when it gets processed. And so I can't do it this way. And so that's why we have this idea of a dynamic array. So I declare the variable without saying how many, I declare the array without saying how many variables I want in the array. It's me saying to the interpreter, hey, I'm going to need an array. And the interpreter's like, well, how many variables do you want in that array? And what am I going to say? I will tell you how many I want when I am good and ready. But for now, you just get ready. That's what we're saying. So before I can use this array, I've got to tell the interpreter how many to put into it. And here's what we do. Instead of saying dim, there is an executable statement called redim to change the dimensions of the array, to redimension the array. Now, I do not change the data type. The data type is fixed up here when I declare the array. So I can't say as string, but otherwise it's the same. I will redim that to the size that I want it to be.
Some sort of maximum length out of space. So is there like a maximum that it can be up to?
This is a really good question. And this indicates that you've got some kind of experience in like computer science or understanding what arrays really are. The important thing to realize here is that, and what he understands, I can tell by the question that he asked, is there's a characteristic about arrays, and that is all of the variables in this array have to be located contiguously in memory. They have to be right next to each other. So I've got to find a block of memory large enough to hold every variable together. That's because it's for performance reasons. We want to be able to go across that array. We want to be able to just read right across it without having to jump to different parts of the memory. It's like, does it take a long time to jump to a different part of memory? No. It takes some time, but not very much time. And we're trying to get it as efficient as possible. And so the question was, well, does it like allocate more so that when you redim it, when you change the size, it can just change the size. And the answer is no, it doesn't. When you redim it, it just finds a block of memory that has enough. And then when you redim it again, it finds a different place. And if you tell it to copy all the values over, it will copy all the existing values over and do it. So redimming is not efficient, especially for a large array, because it's got to like find another place in memory and then copy all the old values into it. Now, we are not copying the old values into it here. There are no values yet. But if I wanted to tell it, let's say I did that here, and then I decide, you know what, I want to go just a little bit bigger. So I'll redim again to hotel count. In fact, let's go ahead and do that. I'm going to run this. I'm going to redim it here. So one bigger, and I'll actually do it after I stop. Okay, I'm going to run to here. Ambiguous name detected. I need to make this a comment. Okay, so at this point, I can look at my hotel array. At the number 3 position, I've got that value. I'm going to come in here and shift F8 or just F8. Now I've redimmed that. So it's now bigger. Like I redimmed it the first time to hotel count -1, and now I get to hotel count. So it's now 0 to 35 here, 0 to 36 here. I'm going to ask what's in hotel number 3, and it is gone. When I redimmed that, it made a brand new array at a different location in memory, and it's empty. I can tell it I want to keep those old values around by putting the keyword here, preserve. So redim preserve, run this again. And let me F8 past that. So now that I've got redim preserve, it's made it to that other size and it's kept it around. But it really did rewrite that array to a different location in memory. So if you're just kind of brand new to arrays, this whole discussion about moving to a different location in memory, you can forget about it because it's not really relevant to using it. But if you're experienced with this and you're trying to think about what's going to be performant, then there's some things about this that you might think, wow, that's really not that great. And that's true. Not a big deal on arrays of this size, but you get arrays that are like tens of thousands of variables, which is reasonable to do. That's going to end up taking time. Okay, that's the idea of a dynamic array. For a dynamic array, you declare it, wherever you declare it without saying how big you want to use it. And then before you can use it, you've got to redim it and tell it how many variables to create. Show me how you are with dynamic arrays, how you're feeling at this point. 5, I'm seeing some 3s. Yeah, it's a little bit, this is kind of a little more complex. I told you we're going to make it harder. It's going to get harder still. Are you ready? Here's the next thing. What we've declared here is what's referred to as a single dimension array. It is, you can think of it as just like one vector of numbers. But I could make this into a multi-dimension array. So I can say, instead of giving it one number to tell it which variable I want, I can say I've got to give it 2 numbers to tell it which array I want. So I can think of this, instead of being a vector, I can think of it as a grid, where I've got to give it a row and a column. Now, the array itself is really a continuous stream of memory, however I declare it. And so this is just a convention about how do you want to access it, and having different number of dimensions might make the problem you're trying to solve much easier, as it will for us, because we're going to do a 2-dimension array now. Question. How many dimensions can an array have? An array can have 3 dimensions, and you can understand it. That's where your brain ends, 3 dimensions, because you can think of it as a cube. But you could, I don't think there is a limit. I think you're limited only by memory. There may be a limit. If only we had some connection to a worldwide network of information, we could find out. There may be, and a Google search would probably be the best thing to find that out. But it's, I've made 6-dimension arrays, no problem. And if there's a limit, it's got to be above 32. Has anyone Googled that yet? As many as 32. So it caps out at 32 dimensions. Yeah. I mean, that makes sense. how many variables can be in your array? That is limited only by available memory. So they can be big. Which, by the way, is when you really need to be thinking about having the right data type. When you're making one variable at a time, having an extra overhead of like 4 extra bytes in the variable, not a big deal. When you're making 10,000 variables at a time in an array, the data type is going to be important. Make sure you've got the data type that's as lean as possible. Okay, so let's look at a 2-dimension array. I am going to need to be able to solve this problem. I'm going to need to have all of these distances loaded into an array so I can kind of count through them and figure out what's the next nearest hotel. And so I'm actually going to make this whole thing as a grid. And I'll do that with a 2-dimension array. Now, I really only need kind of this top triangle half right here, like this, the part that has the data. But to simplify this problem, it would be a lot easier if all this data were filled in. Let me just kind of fill a couple of these in here. This problem is easier to solve if I can say, all right, I am going to, right now, I'm at the, in terms of figuring out the steps, I'm right here at the Sheraton in Phoenix, and I want to find who my closest hotel is. If I'm only wondering how far is anything from Phoenix, I'm only interested in this whole row, because this row shows how far everything is from Phoenix. And so if I fill this grid out, even though it's duplicating data, if I fill this grid out, it's really going to simplify my problem, because I can say, just go across one row and I can find out what the next nearest, I can find out what the smallest number is in that row. If I don't fill this in and I want to find out, like if I'm here at Scottsdale and I want to find out, what the properties are, I've got to go, the distances are, I've got to go look at these 3 different rows and then all these columns here, right? That's where that data is, where that data is. And so if I can take this and put it here, then it's going to be a lot easier. So that's what we're going to do. Yes. Oh yeah, we're going to, by the way, what number is in the diagonal? Yeah, 0. And the good news is that's the default value for all numeric variables. And so that's going to automatically get the diagonal right. And then we'll populate anything in around it. Okay. Oh yeah. So how are we going to keep ourselves from selecting 0? That'll be the smallest number everywhere. Remember, our constraint is that we're going to choose the smallest one that we haven't been to yet. And if I'm at Scottsdale, I've been there. And so this one, if I get that in place to say, I'm only considering the ones that I haven't been to, then this one will automatically come out because I'm already there. So, but we'll get to that. We won't get to that today, but we'll get to that when we get together again next week. But I would like to get this array built and populated before we leave today. So let's get to it. Let's call this, I'm going to call this dist. So let me dim dist as, and it looks like these are numeric values and they're integer values. So I'm going to say, in fact, you tell me what would be a good data type here. What data type should I use for these distances? There are three integer types. They are byte, integer, and long. Which one's best? Yeah, integer, because the range is plus or minus 32,000. By the way, what is the circumference of the Earth? It's only 24,000 miles. 24,000 miles. The circumference of the Earth at the equator is about 24,000 miles. And so if I've got a distance between two hotels that's more than 32,000, that's not a very good route. I mean, that's like going around the world and then some to get there. So I'm pretty sure I'm not going to have a distance, no matter how I expand this problem, I'm not going to have a distance that's going to go above what integer could do. So I like it. So dim dist as integer. Now, again, it's a dynamic array. I haven't said how big to make it. And so once I've calculated my hotel count, I'm going to redim hotel, and I'm going to redim dist. I'm going to do it with constants first, and then I'll put the variable in because I want you to see how the simpler syntax first. So if I've got 35 hotels in both dimensions, I would say I want 35. That's just like hotel. And now I'll say another 35. And so now you can think of this as saying, the first one tells me the row, the second one tells me the column. This one happens to be square, but there's no reason it couldn't be 35 by 100 or something. It can be rectangular. So now what it means, when I want to refer to the upper left-hand corner of my array, it's going to be dist, and I'm going to supply two indices, row number 0, column number 0. And that equals, let's do row number 0, column number 1. And that equals 691. Right, so when I redim or when I dim or redim a multi-dimension array, I just put how many, what's the degree, how many rows there are, how many columns there are, how many, and then when I refer to it, I've got to provide a specific index within the bound, 0 to 35 for this one, 0 to 35 for that one, and that will identify then that one variable that's at that location in the array of variables. Of course, I'm not going to hard code to 35 because the whole point here was to be able to make it the size of the problem to be able to change. And so I will declare it to be 35, maximum index 35 for the row, maximum index of 35 for the column. I'm going to emphasize these are not really rows and columns. It's a metaphor for you to think about it. You could think of these as boxes. I've got 35 or 36 big boxes. And inside each of those boxes is 36 smaller boxes. And the first number tells me what big box to look in, and the next one tells me which little box to look in. Okay, so it's just a numbering scheme to allow you to organize the problem differently. Okay, so now I've got this one built. I'm ready to go ahead and add in my to kind of fill this array up. And I'm going to do it right here inside this same loop. So before I change what row I'm looking at, I'm going to want to go ahead and fill in all the information that I need for that, for the first row of my distance array. So I'm saying I'm picking up a value for my hotel, and now I'm going to pick up a value for my distance. Okay, so right now we're talking about the row. So I'm going to say row -2, same way I did for my hotel. That's going to get me down to this on my first one. And I'm going to do column number 0. We're going to make that a variable in a second, but we're not going to jump to variable straight away. I'm going to hard code the column and just worry about the row at this point. And I'm going to say that equals, and it's going to be distance row that we're on, column number 2. So I want to look in column number 2, and I want to read that value. Now, ultimately, we're going to have to get the rest of these filled in, but let me go ahead and just put these values in the worksheet. For now, I'm going to come here and do a paste transpose to get these numbers in here. And just so you can see this part work. And then we'll extend it to read the whole thing, and we'll change it to read just the values from this triangular portion. Okay, so I'm only ever looking at the zero value in the second dimension. So this should give me this set of numbers in that first dimension of my distance array. I'm going to go ahead and run it. And I didn't like something. row 2. That looks okay. So I should be able to see what this is. And that should tell me. Yeah, so we're actually reading that distance. Row -1 is 3. It's not, oh, someone said that. You said that. I didn't hear you. And you said, oh, I'm just gonna let him figure it out. Yeah, it's row -2 is what this should have been. Let me stop that and run it again. Okay, so now I've never referred to anything besides the 0th position in this array, but I should be able to look right here and say distance row number, here's my 0, here's my 1. So 1, 0, and that should give me that 691 right there. If I look at the next row down in the array, it should have read that value and put it in. Okay, that looks great. But now, I haven't put anything in the second column of these. I've only got that first set of numbers in there. So if I ask, for what's there, what's going to be, what will be here, right? I haven't written anything there, so what's going to be there? Yeah, it'll be 0 because that's the default value for all numeric variables. So this thing starts off full of zeros. Oh. Okay, we may not actually get to doing this triangular part, but we will at least read everything from the screen and put it in. And so what are we going to do? Well, every time we're writing to distance, we don't want to write one value, we want to write 36 values. So I'm going to make another loop inside this one. So let me come up here. I've dimmed row as an integer. Let me dim column as an integer. I'm going to put a new loop right in here that says for call equals, again, 2 to 30, 2 to, and what is it? It is row, it's hotel count plus 1. That should get me to the last, that last value. So now my row is going to stay the same for all of these, but I'm going to write to call -2, and I'm going to read from call. Okay, so I'll run that. Subscript out of range. Did I miss something else here? +1, thank you. Thanks for saying it loud enough for my old man ears to hear it. Call is 3, row is 3, -2 is 1. I'm not sure what I've missed here, but we're out of time. So we'll pick up there next time we get together. We'll solve this problem. And the next step is going to be for us to read not the whole thing, but just the part that has the data. All right. The homework that you have for next class is to look across an array and find the position of the smallest number. That'll be an important part for our next problem to solve. It's probably the hardest homework of the semester. It doesn't compare with a project, but it's probably a difficult homework. So get together with someone and work through it. All right, class dismissed. There's a type mismatch. Yeah, I'm trying to put a 0-length string into a numeric array. It doesn't like it.
obviously mentioned.